Okay, so in this video we're going to be solving past paper questions on binomial expansion. Number 2a. Find the first three terms in the expansion in ascending powers of x of 2 plus 3x to the power 4. Okay, so in this case our a is equal to 2 and b is equal to 3x. So we're going to use the formula for binomial expansion, which you'll find in the MF19. So that becomes 2 to the power 4 plus 4 choose 1 times 2 to the power 3 times 3x to the power 1 plus 4 choose 2 times 2 to the power 2 times 3x to the power 2. Now 2 to the power 4 is 16 plus punch 4 choose 1 into your calculator, you get 4 times 8 times 3x. Punch 4 choose 2 into your calculator, you get 6 times 2 squared, which is 4 times, here be careful to square both the 3 and the x, so 3 squared is 9 and x squared is x squared. And now let's simplify. So that's 16 plus 4 times 8 times 3, which is 96x, plus 6 times 4 times 9, which is 216x squared. And that will be our final answer for part A. Now let's move on to part B. So this is part A. Part B. Find the first three terms in the expansion in ascending powers of x of 1 minus 2x to the power 5. So in this case our A is equal to 1 and our B is equal to negative 2x. So the negative is also part of the B. So be careful and make sure that you actually do include it in your calculation. Okay, so use the formula for binomial expansion again. So this becomes 1 to the power 5 plus 5 choose 1 times 1 to the power 4 times negative 2x to the power 1 plus 5 choose 2 times 1 to the power 3 times negative 2x to the power 2. So 1 to the power 5 is 1, punch 5 choose 1 into your calculator, that's 5 times 1 to the power 4, which is 1, times negative 2x, plus punch 5 choose 2 into your calculator, that's 10 times 1 cubed, which is 1, times negative 2x squared. So make sure you square the negative 2, then square the x. So that will give us times 4x squared. And now let's simplify that. If we simplify, this becomes 1 minus, that's 10x plus 40x squared. And this would be our final answer. Now let's move on to part C. Hence find the coefficient of x squared in the expansion of 2 plus 3x to the power 4 times 1 minus 2x to the power 4. So notice that this 2 plus 3x to the power 4 is exactly the same as A. And notice how the 1 minus 2x to the power 5 is the same as B. So what we can do is we can use the expansions that we found in A and B to substitute 2 plus 3x to the power 4 and 1 minus 2x to the power 5 respectively. So it would become the expansion for 2 plus 3x to the power 4, which is 16 plus 96x plus 216x squared times the expansion for 1 minus 2x to the power 5, which is 1 minus 10x plus 40x squared. 1 minus 10x plus 40x squared. Okay, now they want us to find the coefficient of x squared. So what we could do is we could just completely expand these two brackets and then identify the terms that have x squared and add all those terms together and get our coefficient. But then that would take way too much time. There's actually a much simpler way to do this. So you can identify terms that if you multiply them together from each bracket, they'll give you a term in x squared. So for example, if you multiply 16 from this bracket times 40x squared, you end up with a term in 40x squared. So we've got 16 times 40x squared. It will give us a term in x squared. And if you multiply 96x with negative 10x, you get a term in x squared. So that's 96x times negative 10x. And if you multiply 216x squared with 1, you get a term in x squared. Again, now let's just check, are there any other scenarios in which we end up with an x squared? If you multiply 16 by negative 10x, you get a term in x. That's not what we want. If you multiply 16 by 1, you get 16, which is independent of x. So that's not what we want. And you can keep checking. But you should now see that these are the only terms, these are the only scenarios that result in a term in x squared. So let's simplify each scenario. We've got 16 times 40x squared. 16 times 40 gives us 640. So that's 640x squared. And we have 96x times negative 10x, which is negative 960x, and then we have 216x squared times 1, which is 216x squared. My apologies, this is supposed to be squared. And now let's add up all the three terms that have x squared. So that's 640x squared minus 960x squared plus 216x squared. Punch that into your calculator. That's 640 minus 960 plus 216, and you get negative 104. So that's negative 104x squared. And remember, the question wants us to give the coefficient of x squared. So in this case, the coefficient is the number that comes before the variable. So our coefficient is negative 104. So you then say, therefore, the coefficient is negative 104. And we're done with this question. Let's move on to the next one. Number 5. Give the complete expansion of x plus 2 over x to the power 5. Okay, so in this case, our a is x and our b is 2 over x and n is 5. So this would become x to the power 5 plus 5, choose 1 times x to the power 4 times 2 over x to the power 1 plus 5, choose 2 times x to the power 3 times 2 over x to the power 2. Let's come down here, plus 5, choose 3 times x to the power 2 times 2 over x to the power 3 plus 5, choose 4 times x to the power 1 times 2 over x to the power 4 plus 5, choose 5 times x to the power 0, so I won't write it because x to the power 0 is 1, times 2 over x to the power 5. Okay, so x to the power 5 remains the same. That's x to the power 5. Punch 5, choose 1 into your calculator, you get 5 times x to the 4 times 2 over x. So here we can cancel the 4 and the x, so this would become 3. So that's 5 times this x cubed times this 2. So 5 times 2x cubed. Okay, plus punch 5, choose 2 into your calculator. That will give you 10 times x cubed, and here square the numerator, that's 2 squared, which gives us 4, square the denominator, that's x squared, so we have times 4 over x squared, plus 5, choose 3, that's also 10 times x squared times 2 to the power 3 is 8 over x to the power 3, that's x to the power 3. And then we have 5, choose 4, which is 5, times x times 2 to the power 4, that's 16 over x to the power 4. And then we have 5, choose 5, which is 1, times 2 to the power 5, which is 32, and x to the power 5, which is x to the power 5. Now let's simplify this. So we have x to the power 5 from here, then 5 times 2, that gives us plus 10 x to the power 3, and then we have 10 times this 4 over here, that will give us a 40, and then here we've got x cubed and we've got x squared on the denominator, so this will cancel out to give us an x, so that's 40x, plus 10 times 8, which gives us 80, and then here the x squared will cancel out, and here we remain with an x on the denominator, so that's 80 over x. We come to this part here, that's 5 times 16, which is also 80, over, we've got an x here which will cancel out, so we have x cubed on the denominator, x cubed, and then we have 1 times 32 over x to the power 5, 32 over x to the power 5. And this would be our final answer. We've completely expanded x plus 2 over x to the power 5. Part B, in the expansion of a plus bx squared times x plus 2 over x to the power 5, the coefficient of x is 0 and the coefficient of 1 over x is 80. Find the values of a and b. So we're given that the coefficient of x is 0 and the coefficient of 1 over x is 80, and we're going to have to use this information to find our values for a and b. So notice how x plus 2 over x to the power 5 is the same as the polynomial we had in part A, so we can use the expansion from part A, so that this expression would become, a plus bx squared multiplied by, again we're going to substitute with this expansion over here, that's x to the power 5 plus 10x cubed plus 40x plus 80 over x plus 80 over x cubed plus 32 over x to the power 5. And then the question tells us the coefficient of x is 0. So let's find the terms that will give us a term in x. So if we multiply a by 40x, we get a term in x. So we know that a times 40x is one of the expressions that will lead to a term in x. and then if we multiply bx squared by 80 over x, we'll get a term in x, because the x squared here will cancel out with this x over here, and so that's plus bx squared times 80 over x. And just check to make sure that there's no other expression that will result in a term in x. Okay, so now let's simplify this. This would be 40ax plus the squared here cancels out with the x, so you end up with 80bx. And we're told that the coefficient of x is 0. So our coefficient of x will be 40a plus 80b. We're told that this is equal to 0. So notice how we now have an equation in terms of a and b. We are also given that the coefficient of 1 over x is 80. So let's find the expressions that will result in a term in 1 over x. So if you multiply a by 80 over x, you get a term in 1 over x. So that's a times 80 over x plus, if you multiply bx squared by 80 over x cubed, you get a term in 1 over x. So that's plus bx squared plus 80 over x cubed. Let's simplify. This becomes 80a times 1 over x plus, in this case this would become the x squared cancels out, so that 3 also cancels out, and you end up with 80b times 1 over x. And we're told that the coefficient of 1 over x is 80. So you end up with 80a plus 80b is equal to 80. And if we just divide through by 80 here, you end up with a plus b is equal to 1. So now this means that we have two equations in terms of a and b, and we can solve these two equations simultaneously to get the values of a and b. So let's do that. So we've got 40a plus 80b is equal to 0, and we have a plus b is equal to 1. Let's make a the subject of the formula, and let's substitute it into this equation. So it becomes 40 times 1 minus b plus 80b is equal to 0, which becomes 40 minus 40b plus 80b is equal to 0, which is 40 plus 40b is equal to 0. 40b is equal to negative 40. Divide both sides by 40, you get b is equal to negative 1. And let's evaluate a. A is equal to 1 minus 1. So a is equal to 2. So therefore b is negative 1 and a is 2. And that will be our final answer. Let's move on to our final question. The coefficient of x to the power 4 in the expansion of 2x squared plus k squared over x to the power 5 is a. The coefficient of x squared in the expansion of 2kx minus 1 to the power 4 is b. Part A. Find a and b in terms of a constant k. Okay, so let's start with the first part. We're told that the coefficient of x to the power 4 in the expansion of this polynomial is a. Let's identify the term in x to the power 4. To find the term in x to the power 4, you could just expand the whole thing, but that would take way too long. So what we're going to do is, I want you to just look at the parts that have x only. So from 2x squared, we have the x squared part, and then from k squared over x, want you to just focus on 1 over x, and these are multiplying. Our value for n is 5. So we want two powers that will add up to 5 that we can use on these two expressions in such a way that when we simplify these two expressions we end up with x to the power 4. I don't know if that makes sense, but if we use 3 and 2, 3 plus 2 adds up to 5, 3 and 2 here, this first part will become x to the power 6 and this would become 1 over x squared, and if you had to simplify, this would cancel out and this would become x to the power 4. So remember, these two powers add up to 5, and when we simplify this expression we end up with a term in x to the 4. Now we're going to use that to help us find the term in x to the power 4. So now instead of having to expand the whole polynomial, we can say 5, which is n, 5 choose, and then this power over here choose 2 times, now we're going to use, this is our value for a, 2x squared. So that will be 2x squared, and we've established that our power here is supposed to be a 3 times, this is now k squared over x, so that's k squared over x, and our power is a 2. Okay, and then 5 choose 2, if you substitute into your calculator, that's 10 times 2 cubed is 8, and that's x to the power 6 times, square the numerator, which is k squared, so that will become k to the power 4, and our denominator is x squared, and we've established that these cancel to give x to the power 4. So that's 10 times 8, that's 80, and we have k to the power 4, k to the power 4, x to the power 4. So what this means is that the coefficient of x to the power 4 is a. Therefore, a must be equal to 80k to the power 4. Okay, so now let's find b. The coefficient of x squared in the expansion of 2kx minus 1 to the power 4 is b. Okay, so what we can do here, we know that our n is 4 and we want the term in x squared, so that means we're going to have to put 2kx to the power 2, and remember that our powers have to add up to 4, they have to add up to n, so in this case it means our other power must be a 2, because 2 plus 2 is 4, and then this will be n choose 2, 4 choose 2, 4 choose 2 is 6 multiplied by 2 squared, which is 4, k squared, which is k squared, and x squared times negative 1 squared, which is 1. So this simplifies to give 24k squared x squared, and we say that the coefficient of x squared is b, so that means that b is therefore equal to 24k squared. Let's move on to part b. Given that a plus b is equal to 216, find the possible values of k. So our a is 80k to the power 4, b is 24k squared, and this is equal to 216. Let's put everything on one side, and you should notice that this is a hidden quadratic. If you're not familiar with hidden quadratics, I have a video on hidden quadratics. I won't go too much in depth on them in this question, so if you still don't understand how they work, feel free to watch that video and then come back to this section. So let's divide through by 8 to simplify this quadratic. So that will be 10k to the power 4 plus 3k squared minus 216 divided by 8, that's 27. 27 is equal to 0. And now let's rewrite k to the power 4 in terms of k squared. So that's 10k squared squared, if you had to expand this bracket, 2 times 2 will give you 4, so that takes you back to k to the power 4, plus 3k squared minus 27 is equal to 0. Let y equals k squared, and we can rewrite our quadratic as 10, substitute k squared with y, so 10y squared plus 3y minus 27 is equal to 0. So let's factorize our quadratic here. We have 5y here and 2y here is equal to 0, and we can do 9 and 3, so 5 by 3 is 15, and 2 times 9 is 18, so we want positive 18y minus 15y to give us 18 minus 15, which gives us 3, and 9 times negative 3 gives us negative 27. So here we'll get y is equal to negative 9 over 5, and y is equal to 3 over 2. Now let's go back to our statement that said let y equals k squared, and now we're going to reverse it. So where there's a y, replace with k squared. So it becomes k squared is equal to negative 9 over 5, and you've got k squared is equal to 3 over 2. So to get rid of the power 2, we have to take the square root of both sides. But we know that we cannot find the square root of a negative number. So that means in this case, k has no solutions. And now let's evaluate k squared is equal to 3 over 2. So take the square root of both sides. You end up with k is equal to plus or minus the square root of 3 over 2. And remember, we always put a plus or minus sign when we are taking the square root of a number. And this will be our final solution, that k is equal to plus or minus the square root of 3 over 2. So that's it for today's video. Thank you for watching. If you liked it, please subscribe for more videos like this. Goodbye.